So our goal is to do just page 2 and part of page 3. Okay, we already did that page. So let's talk about classifying polynomials. This is an Algebra 2 topic. You might see it in Algebra 1. I honestly don't remember if it's just Algebra 1 exclusively. So there's ways to classify polynomials, like a binomial, trinomial, things like that. Polynomials, so up top, polynomials are named by their degree and terms. So page 2 is just to kind of prep us with being able to read a word problem and it's describing a polynomial to us and us being able to understand what that means. So polynomials are named by their degree and by their terms. Okay. What is a degree? If I want to know what a polynomial degree is, where do I look? The exponent, yes, good. The degree is the largest exponent. Degree is the largest exponent. That's true if it is only one variable. If you look down at the bottom right-hand corner of your notes, we have x and y together. If you have more than one variable in part of the term, you add the exponents together. So if you have multiple variables in a term, which we'll talk about a term in just a little bit, but a term is kind of like a little cluster separated by a plus or minus. So if you have multiple variables in a term, you want to add the exponents. And this is not us applying exponent rules. We're just adding the exponents regardless of the letter, because that's how we want to classify a degree. So we're not combining those, we're just identifying degree. So the exponents go with the terms. It doesn't matter if it's an x and a y, you can still combine them when you're calculating a degree. So a first degree is 0 degree. So an example of 0 is 7. What do we call just a number? Besides a number? It starts with a C. A constant. This has a 0 degree. This is referred to as a constant. It's called a constant because it never changes. 7 is 7. Numbers can change when variables are introduced. So a constant is just stays the same forever. 7 is 7. 8 is 8. What about a degree of 1? An example could be 3x plus 2. What do we call something with a degree of 1? Coefficient is the number in front of the exponent. But if our exponent is just 1, envision graphing that. If I graphed that, what would that look like? 3x plus 2. Linear. Good job. So if it has a degree of 1, we refer to this as a linear. The reason it's linear, it has the word line in it. If I were to graph it, it would just be a line. One exponent is a line. Now, I'm sure that could increase or decrease depending on the slope, but it's just a line. Okay? So linear has a line in it. If we've got a power of 2, such as x squared plus 3x minus 7, what do we call a power of 2? That's a quadratic. So a power of 2, a degree of 2, is referred to as quadratic. And a basic quadratic, just x squared, what does it look like when I graph that? Yeah, it's a parabola. Looks like a U. And the parabola can change depending on the coefficient values, but we'll get into that later. For now, this is just what it looks like when you graph it. It looks like a U. It's called a parabola, and it could cross the x-axis maximum of 2 times. Okay. What about a third power, like x cubed plus 2? X cubed plus 2. What do we call that degree, power of 3? Starts with a C. Cubic. Yeah. So power of 3 is referred to as a cubic. And depending, again, with the coefficient in front of the x cubed, it looks like this. So it just increases the number of turns it has. It could potentially cross the x-axis 3 times. Okay? As you go up in powers, the number of curves go up as well. What about a 4th degree, like x to the 4th minus x plus 7? 4th degree, what do we call those? There's 4 of these in $1. It's something about a quarter. It's called a quartic. Quartic. So 4th degree is quartic. Okay. Then we've got the last one, a power of 5, so like x to the 5th minus x squared. 5th power is what? It's been a while, it's okay. This is quintic. So if you have quintuplets, you have 5 children at the same time. Anything higher than 5? Yes, Jasmine, good job. You can always unmute yourself and just yell at me if you want to answer. So anything higher than 5, it does have names, but I don't care about what their names are because the ACT doesn't care about what their names are, so you don't really need to know anything past 5. However, if the power is greater than 5, if our degree is greater than 5, it's just called an nth degree. So regardless of what the number is, we just call it an nth degree. So if our degree was 25, if our highest exponent is 25, we would call it a 25th degree. We just replace the n with the highest power. So yes, there are names for things above 5, but you just don't need to learn them for the ACT, so we're not going to focus on that. Our goal is ACT. Okay? So that's how you name it based on degree. What's a term? Yes, good. A term is a group of values. It's a group of values separated by a plus or minus. So the number of terms does not have to match the number of degrees. Degrees is the highest exponent. Terms are groupings of values separated by plus or minus. So you want to look for groupings of plus or minus. So 5x squared. That has one term. There's no plus or minus in this. What is a one-termed polynomial called? There's an M. Monomial. There you go. Mono meaning one. Monomial. Okay. Monomial just is one term. So what's a two-term called? Binomial, like bicycle has 2 wheels. A binomial could be like x plus 3. Notice I have an x, and then I have something separated by a plus or minus with a 3. Binomial, 2 terms. 3 terms? Trinomial, yeah. We all know that one. When we factor, we usually factor trinomials. So that could be like 5x squared plus x minus 10. 3 terms. Anything larger than 3 terms, what do we call that? It is just a polynomial, yes. So anything larger than 3 is polynomial. Okay. Now, there are some ACT questions out there that it could say, okay, here are my answer choices. The answer is a binomial with a coefficient of this and a C value of 7. Like if you know what those words mean, you can answer that question. It's mostly just vocab. So let's practice classifying real quick, and then we'll get into the factoring part. So down here, let's practice classifying the first one by degree and by term. So what is the degree of this first example? Okay, good, is quintic. So notice how I have one variable here. My largest variable is 5, so that is quintic. The degree is the largest power. How many terms? We were going to classify it by terms. Trinomial, 3 terms. I have 1, 2, 3, trinomial. So if we were going to classify that polynomial, we would call it a quintic trinomial. Okay. What about the second example where we've got 2 variables here? What is my degree? It is quartic. How did you get quartic?
I just added the first 2 to the first.
Perfect. So we got a power of 2 and a power of 2. They are in the same term. You only want to add the same terms. So I'm going to add those, and when I add them, I get 4. So 4 terms is quartic. Number of terms? Yes, this is a polynomial. 1, 2, 3, 4. So again, this page is just to make sure that we can understand how to name these things, because if we're reading a word problem and we don't know what these words mean, it gets a little bit difficult to understand. Okay. So let's talk about factoring for about 15 minutes until I give you back your test. All right, so we're going to be on page 3. For second period, only really got to a equals 1, and then we did a little bit of factor by grouping. So I definitely don't expect us to finish all these notes today, but we do want to start to factor. We're going to spend a couple days on it because it's something that we easily forget. Also, multiplication skills, we just need help on that. It's okay. So knowing your multiplication skills makes factoring a whole lot easier. If you can multiply some numbers, this isn't as hard. So what is one of the most important things we have to know when we factor? Okay, pull a GCF out. What about this equation? I cannot start factoring. It's got to equal 0. Everything has to be on one side of the equation. So the first thing we have to remember is your equation has to equal 0. Your equation must equal 0. That is one of the most important things. You can't factor and pull out that GCF or look for common terms until it equals 0. Everything has to be together. So in the quest for making things 0, what do we have to remember about x squared? Or a squared variable. What has to be true about that before we start? Can it be any old sign? I don't care what it is. It can be positive or negative. You always want x squared to be positive. Now, you can factor when x squared is negative, but it's a lot harder and you mess up a lot quicker. So x squared must be positive. To make your life easier, make it positive. It can be done if it's negative, but I just wouldn't do it. It'll make your life a little bit harder. So keep x squared positive and make your equation equal 0. So when we use the term a equals 1, in a trinomial, it looks like this: ax squared plus bx plus c equals 0. That's the generic term. Okay. If the a value equals 1, you can use the shortcut, not factor by grouping. So I'm going to show you the shortcut. I know most of the Algebra 1 teachers, I think they always teach factor by grouping all the time, forever and always, but there's a lot faster way to do it. So as long as your a value equals 1, we can do a shortcut. So what should we do first here? Yes, and you want to make sure to keep it in the same order. X squared first, then X, then the constant. So we got X squared minus 5X minus 14 equals 0. How do I factor? What should I do? How do we factor this? Remember, factors are just where the equation or graph crosses the x-axis. So what should I do? Mm-hmm.
And then whenever you get, in this case, 14, you find the two numbers that will multiply to 14.
Yes.
And also add the negative.
There you go. So in this one, so that's like called the AC method. So anytime A equals 1, you're basically just multiplying. 1 times negative 14 is negative 14. Two numbers, I got to have them multiply to negative 14. Those same two numbers have to add to equal what? That negative 5 term in the center. Okay? So anytime you're factoring, it's really important to pay attention to the values. So I'm looking for this value here. And in this case, you don't have to think 1 times C because 1 is A. But you're always multiplying to get the A times C value. And then you're always adding to get the B value. And you want to pay attention to the sign. I'm not just going to put positive 14 and positive 5. The sign makes a difference. So what two numbers multiply to negative 14 but also add to negative 5? 2 and negative 7. I'm going to put negative 7 first. Just, I don't know. Let's say that you knew it was 7 and 2, but you're unsure of the signs. Focus on the numbers first. So think of all the factors of 14, and then start playing with the positives and negatives. So if you're having trouble identifying which one should be positive, which one should be negative, focus on just the numbers. Then play around with signs. Another thing that is very important when you factor, the values have to be the same. So like negative 7 has got to be in the multiplication problem and the addition problem. And this one has to be in both as well. Like you have to be the same. Okay? Now they could eventually both be 2 or both be negative something. But they have to be the same numbers. How do I break it up down here? Oh, you're doing long way. Have they shown you the shortcut?
No.
Your algebra, you didn't. I'm going to show it to you because you're going to like this. All right. When A equals 1, you don't have to do that. So when A equals 1, you can automatically break it up into parentheses. And you can get X and X. So you break up your X, and then you take these values and you put them right here. Now you can do that. That's factor by grouping. If you love factor by grouping, do it. But if A equals 1, you can always do it this way. So it just saves you a little bit of time. If you're fast at factor by grouping, it's totally fine. But if A equals 1, you can break it down to where you just break it into the 2 parentheses and then solve. If you don't like that method, it's totally fine. You don't have to do it. You can do factor by grouping. This just saves you a little bit of time. So when you're actually solving this problem, you will only solve it if you have an equal sign in it. Like if there's no equal sign and it just says factor, you stop here. If there is an equal sign, then you solve it. So how do we solve it? Yeah. X minus 7 has to equal 0, or X plus 2 could equal 0. Solving for X, you would get an answer of 7 and negative 2. If you do factor by grouping, you get the same answer. It just might take you a minute longer. And on the ACT, knowing the shortcuts will save you some time just to help you. Now, if A is greater than 1, factor by grouping is the way to go. So we'll start this example. We probably won't finish it, but that's okay. So what do we have to do first for factor by grouping? There we go. Yes, I got to move this term and this term. My x squared value is negative. To make my life easier, I want it to be positive. So 3x squared, I'm going to keep that negative 2x, subtract 5. Since there's an equal sign has to stay in your problem. Now we're going to do that AC method where we multiply the A times the C value. So again, we're looking for two numbers now. And instead of them just multiplying to -5, we need them to multiply to -15 because the A value is 3 and the C value is -5. So you take 3 times -5, or A times C, to get -15. You want to multiply them together. Now when A equals 1, that doesn't really make a difference because 1 times whatever is just itself. Okay. Then we've got to add those numbers, those same numbers, and they are still going to equal that -2. Okay. So what are my two values? 3 and -5. -3, -5, and 3. They have to be the same. You can write them in either order. 3 minus 5, doesn't matter. It's up to you. Okay. But those both check out. Now again, if I'm struggling with the negative signs, I'm just going to focus on the numbers that multiply to 15 and then play around with those numbers. This is where we break it up. So whenever the A value is greater than 1, you can't use this shortcut. You have to break it up by factor by grouping. So my 3x squared stays. Instead of writing -2x, this is where we write these terms. -5x plus 3x, and then we still have our -5. So if factor by grouping is your thing and you love it, you can do it all the time. It works all the time. Okay? It just might be shorter or save you time if A is 1. Now to factor by grouping, you group the first two terms, 1, 2, and you group the second. Okay. This is where you look for the GCF. So in the first group of parentheses, what's my GCF? It's just x. So I get x. So when I pull out that GCF, what am I left with in those initial parentheses? Yeah, 3x minus 5. Remember, the goal of factor by grouping is to get two parentheses that look identical. So in this parenthesis, my goal is to make this one look just like it. Does it? So what do we pull out here? A 1. You have to pull a 1 out because we need a binomial times a binomial. So I'm going to pull out a positive 1, and I'm just left with 3x minus 5. How do we regroup those together? X plus 1. So this goes in one parenthesis. It doesn't matter which one you write first. Usually you pull out the GCF and you put that one first, but honestly, it does not make a difference. Okay? How many times do we write the second parentheses? Just once. These are identical, so they just get written one time. 3x minus 5. Since it equals 0, we set each parenthesis equal to 0. And again, the reason you set each one equal to 0 is because either parenthesis could have a value of 0, making all of it 0. That's why we set each individual 1 to that. So x could be 1, or x could be 5 over 3. And you might see your answer choice written this way. It just depends on how the problem's written.